Hi, in this video we are going to look at summarizing quantitative data. In the previous video we looked at methods by which we can summarize qualitative data, where we looked at bar charts or bar graphs, we looked at pie charts, and we also looked at constructing a frequency distribution for qualitative data. So the reference text that I will use and the examples and some of the tables and graphs are taken from Elementary Statistics by Mario Traiola. This is quite a useful text in that it lays out the underlying principles in a manner that is highly informative, and easy to understand and easy to follow as well. So the learning outcomes. So by the end of this lecture, you must be able to construct a quantitative frequency distribution table for both grouped and ungrouped data, right? We'll look at what this means, grouped and ungrouped data. You must also be able to interpret findings from a quantitative frequency distribution table, which we'll go through as well. And in the next video, the video after this one, we will look at using the quantitative frequency distribution table in order to construct the histogram and also to construct a frequency polygon. Okay, so in dealing with data, it is important, especially for descriptive purposes, to be able to look at 5 characteristics and be able to talk about those characteristics. And the first one here is the center of the data. So what we mean by center is a representative value that indicates where the middle of that data set is, right? So it's basically what we call the average or the arithmetic mean, or simply the mean. Number 2 is we are also interested in the variation. How spread out are the data points from the mean? And to measure variation, we usually, at minimum, we would use 2 related values, that is the standard deviation and the variance. If you are familiar with the standard deviation, you know that the standard deviation is basically the square root of the variance, right? So these two are related values. So variation is basically a measure of the amount that the data values vary. And this will become apparent and quite easy to understand as we go through the course. Distributions. So this is the nature, rather, or the shape of the spread of data over the range of values. And we will look at such graphs as the normal distribution, right? The bell-shaped curve. And we have what is known as outliers. These are values that lie very far away from the vast majority of other values, and they're usually very small values or very large values. So the other factor, the last factor that we are interested in, is change over time, right? So the changing characteristics of the data over time. How does the data vary or change over a specified period of time? And with line graphs, usually we would get to appreciate how the data vary over time. So these are the 5 characteristics that you have to have etched, right, on your memory when you talk about or when you describe data. So the center, the variation, the distribution, outliers, and time. So the frequency distribution. Within the frequency distribution, we would have what are known as classes. So a class is basically a category into which a score or a data point can be placed. And it is a single score, right? That class or that category is a single score in an ungrouped distribution, right? And of course, in a grouped distribution, it's a grouping of scores. So the difference between a grouped and an ungrouped distribution is that when we talk of a grouped distribution, which is what you will most usually come across, we are talking about a situation where you summarize your data points by grouping them into classes, right? The reason we do this is to simplify our analysis, right? So when you talk about a grouped distribution, we are talking about a situation where you group your data points, right? So instead of having single scores, you group them. So you may have a class that starts at maybe 1, 2, 3, which means that this class includes all data values from 1, 2, 3. Okay, so this is what we call grouping, right? This is important because it actually summarizes your data, and it makes your data easy to manipulate and easy to work with, right? And in the next few slides, we'll spend some time familiarizing ourselves with grouped distributions. So the end numbers of the class interval are what we call the class limits, right? Or score limits. So again, we'll spend some time learning these terminologies. This is a simple frequency distribution. How do we know that it's a frequency distribution? We can see that it has classes, and of course it says frequency right there, right? That's easy. And it shows that how the frequencies are distributed across the different classes. Okay, so the thing to note here is we have how many classes? 1, 2, 3, 4, 5, right? And within the first class, we have 2 data points, right? So this is what this is basically telling us. And within the second class, we have 33 data points and so forth. 35 data points in the third class, 7 in the fourth, and only 1 data point in the fifth. Okay, so it's important also to note that we don't actually know what these data points are. Okay, we only know that there are 2 data points between 50 and 69. We don't know the exact numbers. And we also know that there are 33 between 70 and 89. We don't know what those exact numbers are. In order to know that, we would have to go back to the raw data, right? Remember, a frequency distribution just summarizes the quantitative data. So this is summarized, right? If you wanted to know what these exact numbers were, you would have to go back to wherever the raw data is, and you'd get that information. Okay. Okay, so now to emphasize the terminology. So the lower class limits are the smallest numbers that can actually belong to different classes as shown there, right? So this is straightforward. These are the lower class limits of our classes. The upper class limits are the largest numbers that can belong to different classes, right? Again, as highlighted there. The class boundaries are the numbers used to separate the classes without leaving gaps, right? Gaps that are created by class limits. If you look at the first and the second class, you will notice that between 69, right? Between 69 and 70, there is a gap there, right? So there is a gap of 1 that is not accounted for, right? In order to avoid leaving these gaps, sometimes it's necessary to use what is known as class boundaries. Okay, class boundaries would basically be numbers that are midway between 69 and 70, or midway between 89 and 90. So in order to get that number, you'd basically be adding 69 plus 70, then you divide that by 2. So you'd get 69.5. So if you are going to be using class boundaries for your classes, instead of having 50 to 69, you would have the first class would be 49.5 to 69.5, right? And the next class, which is the second class, instead of it being 70 to 89, it would start at 69, right? It starts where the first class ended. So 69.5 to 89.5, which means that in that case, there is no gap created by the class limits, right? So there is no gap there because the first class ends at 69.5 and the following class would then begin right at 69.5. Okay, and so forth. So this, we call them class boundaries. Okay, what about class midpoints? Class midpoints are the values in the middle of the classes, and they can be found by adding the lower class limit to the upper class limit and then dividing that by 2, right? It's easy to find the midpoint of this class. You would add 50, right, plus 69, and then you divide that by 2. It will give you 59.5. The reason why the midpoint is important is, remember previously I said, we don't actually know the numbers that are in this group. We know that there are 2 numbers, right? There are 2 data points. We don't know those exact numbers, what those exact numbers are. But the midpoint, what it does is, it gives us a representative number for that class, right? So which means for the first class, the representative number is 59.5. For the second class, the representative number is 79.5. For the third class, the representative number is 99.5, which means we can basically conclude that we have 59.5 times 2 59.5s in this class, and we have 33 79.5s in this class. So that's a way to simplify and summarize the data as well. But remember that if you did indeed want to know exactly what these data points were in these classes, you'd have to go back to the raw data, the unsummarized data. So the class width I've already spoken about. So I said is the difference between 2 consecutive lower class limits or 2 consecutive lower class boundaries, right? So to find the class width, you'd subtract 50 from 70. So you'd go 70 minus 50, or 110 minus 90, right? So the difference is 20. So that is the class width. Okay, so reasons for constructing a frequency distribution. Why do we have to learn how to construct a frequency distribution? It's easy, as I've already said, is because large data sets can be summarized. We can also analyze the nature of the data after we construct a frequency distribution table. And we also have a basis, right, where we can now construct important graphs such as histograms, such as frequency polygons, such as cumulative frequency curves, right? So that's why it's important to really understand how a frequency distribution table is constructed. Okay, so let's spend some time going through steps that will help you in constructing a frequency distribution. The reason why these steps are important is because if you follow these steps and you have a system by which you can do this, you will make less mistakes, right? So it is important to have a system that you work with, right? So the first thing to do when we are constructing a frequency distribution table is to determine the number of classes that you would need. Unfortunately, this is not really an exact science. You'll have to look at the distribution or the data points that you are working with and decide how many classes you would need in order to display those data points accurately or accordingly. So, but the rough guideline is that you should have anywhere from 5 to 20 classes, right? 20 being the maximum, 5 being the minimum, right? So again, this will just come by practice as you work through different problems. Okay, so that's the guidelines there. So you decide the number of classes that you'd need in your distribution, and second, you calculate the class width, right? And it's important that when you calculate the class width, you round up. So how do you calculate the class width? The class width is given by the maximum value in your data distribution, right? The maximum value minus the minimum value, which is the range. This is range. And you divide that by the number of classes, right? The number of classes, remember, you have already determined them in point 1, right? So you will take the maximum minus minimum divided by the number of classes. That will give you the class width. So whatever number you get, let's suppose you get something like 6.2. You round this up, right? This is counterintuitive because a number like 6.2 would, by the rules of mathematics, be rounded down to 6. But here we are dealing with the class width, right? So the reason why we round up is, what this is telling us is you have the class width is 6 with a 0.2. So what you want, if you want to simplify your distribution, you don't want a class width that would have a number like, let's say 1, and then you have something like 1 to 7.2, right? Or something like that. You wouldn't want that, right? You would want whole numbers. And that's why we round up, okay? So the third point is, after having your number of classes and your class width, you choose the minimum value or any convenient value to start off at, right? Usually, this will be the minimum value in your data set, right? It's just easy that way. You just start with the minimum value in your data set. So after you determine the minimum data value, which is the first lower class limit, you use it then to list other classes, right? So you'll be using the first lower class limit and the width to then list the other lower class limits, right? So let's suppose your lowest data point was, by the way, we'll have an example in the next few slides. Let's suppose your lower data point was 1 and your class width was 3, right? So it means that in your distribution, you'd have 1. Since your class width is 3, you'd add 3 to this first lower class to get the second lower class. So your second lower class would be 4, your third would be 7, and then 10. Okay, so this would be your lower class limits. And then you would proceed to then list the upper class limits by following more or less the same procedure. So if the first lower class is 1 and the second lower class is 4, it means that the upper class limit of the first class is 3, right? And then since our width is 3, we keep on adding 3 to determine the subsequent upper classes, right? Or upper class limits. So we'd add 3 to 3, we get 6, we get 9, we get 12, just like that, right? So this will become clear as we work through an example in the following slides. And then after that, of course, if you have your data points, you tally them up and you determine the frequency. Right, so let us work through this example in order to cement, right, the steps that are used to construct a frequency distribution. You have to have this well laid out or memorized, basically, so that you can be able to work through the steps in an exam or test situation. So assume the following quantitative data of body weight and construct a frequency distribution. Okay, so this is body weight in kilograms, right? So this is in kgs, right? Kilograms. And these are the data points that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. This is how the frequency distribution would look. So we'd have our classes here, right? And then we have our tallies, our tally marks, frequency, relative frequency, and then the cumulative frequency. So by doing this, we have a complete frequency distribution table that we can then use to construct graphs if we so desire. Okay, so let us start first of all by determining the classes. How many classes are we going to have? I've already predetermined the classes here. We are going to have 1, 2, 3, 4, 5, 6 classes, right? So 6 classes that we are going to have. In order to calculate the width of each class, remember, let's go back to the steps so that you appreciate. So the class width is the maximum value minus the minimum value divided by the number of classes, right? So I have already said the number of classes will be 6. Okay, so we have 6, and so let's calculate the class width. The minimum value here that we have is 20. The maximum value is 49, right? So our class width is equals to 49 minus 20. Divide that by the number of classes, which is 6. So 49 minus 20 is 29. We divide that by 6. We would get something like 4.8, right? So remember we said 4.83. Remember we said we round up. So this is 5. So it means that we are going to have a class width of 5 in these 5 classes, right? So the next step, remember, was we pick a starting point. So the starting point that we'll pick here, remember, it can be any convenient value, but it's always easy to just pick the lowest value on your distribution or on your data points. So in this case, it's 20. So we'll pick 20. That's the lower class limit, right, of the first class. And then what we do is we start listing the other lower class limits, right, by using the class width, right? So we add the class width to the previous lower class limit in order to get the next one. So 20 plus 5 gives us 25, and then we would have 30, 35, 40, 45, right? So we have listed all the lower class limits for all the classes, and then we proceed now to list the upper class limits for all the classes. So we would have 24, right? 24 plus 5 would have 29. 29 plus 5 gives us 34. 34 plus 5 gives us 39. 39 plus 5 gives us 44. And then 44 plus 5 gives us 49, right? So we have our 6 classes, all with a class width of 5, right? If you determine the class width by saying 24 minus 20, this will give you 4. But remember that we start counting from 20, right? This class width includes 20. So if we go 20, 21, 22, 23, 24, you see that we have 1, 2, 3, 4, 5. So our class width is 5, right? The same applies to the next one. If we go 25, 26, 27, 28, 29, so we have 5 there. That's our class width, right? So it's not a straightforward subtraction in order to determine the class width, right? That's why we do it this way, by first of all listing the lower class limits and then listing the upper class limits, so that we don't make mistakes in determining the class width. Okay, so having done that, now our job is much easier. What we will do now is to tally basically, and then determine our frequencies. So let's start off with, we have 20. 20 would be in this group here, so we make a tally there. 25 would be here, we tally. 30 is in this class, we tally. 20, 40 is in this class. 35 would be in this class. 40 over here. 49 over there. 25 over here. 40 in this class. 42 in this class. 44 is in this class as well. So we have 5 there, right? So we have tallied. So then we just write our frequencies. So that's easy. 2, 2, 1, 1, 5, 1. Our total there is 2, 4, 5, 6 plus 5, 11 plus 1 is 12. So that's our total. Our relative frequencies, remember I said with the relative frequencies, what we do is we take the frequency of that class, right, which is 2. We divide that by the total of the total frequencies, which is 12. Then we multiply that by 100. So in this case, we get 16.67. This also will be 16.67, right? This one would be half of this, which is 8.33, right? And so forth. So you can complete the table. And for the cumulative frequency, you can either have a cumulative relative frequency where you add the relative frequencies successively, or you can have a straightforward cumulative frequency where you add the successive frequencies, right? If you are going to add successive frequencies, then you'd have 2, right? You add frequency for the second class, you get 4. Frequency for the third group, you get 5. 11 to 1, you get 12, right? So this is the cumulative frequency. Okay, so let's move on. So this is how the table would look, right, if you do everything right. Okay, so we know that the range was 29 there. The number of classes we had said 6. The width was 5. The lower limit 20, and the upper limit of the distribution is 49. And we have our tallies, frequencies, relative frequencies, and our cumulative frequencies. Okay, so this is all for this particular video. In the next video, we'll actually now look at the graphical representation of quantitative data using histograms, frequency polygons, cumulative frequency curves, and line graphs. And it's important that you understand how to come up with a frequency distribution table, just like we did, so that you then have a basis to work with these graphs. Subscribe and share the video. And if you have any comments or questions, write them in the comment section below.